Okay, now we are going to get started, but first I'm going to introduce you to a term that has been used quite commonly over the past couple of years, and at least it has been this particular term has become popular, lost its popularity now and then over the course of past few decades, and that word, it has a very particular ring to it, and that is artificial intelligence. Now the term itself, artificial intelligence, it conjures up a lot of images in one's mind, including images of computers taking over the world. Indeed, when I was a young girl, we actually had a book chapter or an English language chapter related to an artificial intelligence machine taking over the world. But what does artificial intelligence really mean? In its simplest form, it's simply the creation of intelligent machines, specifically designing machines or computer programs that can mimic human cognitive functioning. Example, something like learning. Now, Professor Kapalan described AI as a system's ability to correctly interpret external data, to learn from such data pretty much the way we people do, and to use those learnings to achieve specific goals and tasks through flexible adaptation. Modern day AI was born in 1956 in Dartmouth College when computers of that day were taught to play games. Over the decades, interest in AI has risen and then declined sharply. Right now, we are at a time where artificial intelligence is seeing a golden era where people are applying artificial intelligence in a wide variety of fields, something no one thought was possible even 5 years ago when I started my PhD. So, now artificial intelligence, I was introduced to this term when I was in primary school, and this was a newspaper headline, I recall, and it went, "Artificial intelligence is taking over the world." And then we had this particular image. This is the image of world chess champion Garry Kasparov and the chess game that he played with the IBM Deep Blue chess computer. In the mid 1990s, IBM's Deep Blue computer stunned the world by becoming the first machine to beat a reigning world chess champion in a 6-game match. Kasparov had previously defeated Deep Blue in 1989, and IBM was initially accused of cheating. And yes, Mr. Kasparov too accused IBM of cheating, but as we know, that was the time when the power of artificial intelligence had been harnessed to do something quite spectacular. 2 decades later, AI is still at it. Now artificial intelligence is by far more developed than it was all those years ago. Google's AlphaGo program, which used AI, defeated the world number 1 in the board game Go. This is an East Asian board game, and this is by far more complex than chess. Deep Blue's victory at chess showed that machines could rapidly process huge amounts of information the way we people do. But AlphaGo's triumph represents the development of real artificial intelligence by a machine to recognize patterns and learn the best way to respond to them. And that's a sort of human cognitive reasoning, and day in and day out, and since the time we are born, most of us, we learn to recognize some kind of patterns and then we respond to them. Now, some common terms that are tossed about, and that brings me to the meat of this lecture. Artificial intelligence, deep learning, machine learning, how do they tie in together? Deep learning is a subset, while artificial intelligence is an all-encompassing field. As you can see over here, it's this red circle. Deep learning is a subset of machine learning. So within artificial intelligence, we have machine learning, and overlapping with artificial intelligence is data science. And deep learning, it falls fairly and squarely in machine learning. There are many people who use deep learning and artificial intelligence interchangeably. That is a bit inaccurate, because what you have is that artificial intelligence contains machine learning, which in turn contains deep learning, and it aims to mimic the activity in the neurons of the neocortex, which is the thinking part of the brain. Now, artificial intelligence, it again made waves in 2012, and it was in the same year as the AlphaGo victory. It started recognizing cat videos. A neural network of 16,000 computer processors with 1 billion connections was allowed to browse the YouTubes. 10 million thumbnail images were taken from YouTube as training and then tested to identify whether this neural network could identify objects. And this artificial intelligence system managed to learn how to recognize a cat without any prior training. Cat videos are rather popular on YouTube, and just by processing all of this information, it could actually recognize a cat, and this is so powerful. But then, by now you must be wondering, why should I care about any of this? Now I'm going to talk you through a couple of applications, some of the most common cutting edge applications of artificial intelligence, and that will let you see how things like artificial intelligence and deep learning are powerful and important tools, especially in the image processing domain. AI application. A common AI application has been to detect cancer. Google's deep learning algorithm Lina was taught to examine the images at different magnifications, and that's how pathologists work. And this algorithm showed that Lina was able to correctly distinguish a slide with cancer 99% of the times, and even in situations when the regions were too small to be detected by pathologists. More medical applications have included being able to detect skin cancer with an algorithm known as convolutional neural networks, and this algorithm had a 95% accuracy as compared to 86.6% accuracy that dermatologists can manage. And using this particular system, this malignant pleural whatever could be detected with 97.74% accuracy. So, different deep learning applications are able to detect cancer with more accuracy than doctors and pathologists. In the financial field, artificial intelligence has been used for fraud detection and for stock trading, and basically for predicting the movement of currencies and equities. Another very interesting application of artificial intelligence is saving endangered species. And now artificial intelligence is being adopted in wildlife monitoring. Joint efforts from the University of Wyoming, Auburn, Harvard University, Oxford, Minnesota, and Uber AI Labs has resulted in an accurate method for automated animal identification from camera trap images. Deep learning was able to obtain 96.6 accuracy in terms of species identification, and deep neural networks could successfully identify the count, describe the animals in camera trap images, as you can see here, and essentially this can be very useful for monitoring endangered species like lions in Africa, where it's difficult to track them manually.